Oh! Estamos chegando no último slot da Campus Party Portugal, edição digital. E olha, não vão embora quando acabar, que no final a gente vai fazer um encerramento aqui com todo mundo. Mas antes, eu gostaria de pedir desculpas públicas ao João Miguel Mesquita. João Miguel, eu errei. Eu te mandei o link errado. Me perdoa, meu querido. Nós vamos realocar você agora para um outro palco, que é o palco New Horizons. Colocaremos você no palco New Horizons. Você me desculpas. Eu dei a informação que você não tinha aparecido e a malta estava a pensar que você estava dormindo ou que você não apareceu, mas você estava plugado no link que eu te passei errado. Mil desculpas, João Miguel, mil desculpas do fundo do meu coração. Quando eu estiver no Porto, vou te levar ao Rio Douro para comer uns percebes e te pago o vinho. É por minha conta, para me desculpar, por favor, se você ainda me desculpar. Ok? Então agora a gente vai seguir com o João Miguel para o palco New Horizons, assim como a gente vai ter Gabe meu grande amigo Gabe Gabrielli. Gabe Gabrielli, o engenheiro-chefe da NASA, reformado já, que me deu a honra de ter o meu nome inscrito na parede da fama do John Kennedy Space Center, que eu fiquei muito honrado com esse prêmio que ele me deu, de colocar o meu nome junto com a minha esposa na parede da fama lá do Space Walk of Honor do John F. Kennedy Space Center. Para mim, Gabe, que gratidão e que honra te receber na Campus Party Portugal. Vai ser muito legal escutar o Gabe, que é uma pessoa inspiracional, uma pessoa inspiradora, vai inspirar todo mundo aí. E teremos também o Alexandre Niuzi, que é o cofundador da Remessa Online. Com vocês, os três grandes palestrantes do último slot da Campus Party Portugal, edição digital.
Hello, everybody. This is Gabe. I'm in Cocoa Beach, Florida. I want to say hello, and I want to thank Tonico for this wonderful opportunity. I've been to 7 campus parties in Brazil. I've been to 1 in Singapore, and now I have this other opportunity. So I want to thank Tonico so much, and also his wife, Angela, who are always so kind to me. So today we're going to talk a little bit about Mars and the rovers on Mars, what they're doing on Mars, and how they got to Mars. But before that, I just want to tell you a little bit about me. I was a contractor engineer for NASA at Kennedy Space Center. I dealt with roads and bridges, kind of a civil structural type environment. I really didn't launch the rockets and I really didn't build them. I would love to do that, but I didn't have that opportunity. But it's not what you do, it's where you do it that makes it so special. So we're going to talk a little bit about Mars. I'm going to share the screen here. Okay, so did you see the part of the movie? Okay, so how, I don't know if what you heard, but I want you to count down when the engineers count down. Hopefully it will work this time. Okay, let me get back to the movie. Yeah. Okay, so it should show, hopefully. Okay, okay. Okay. No, it's okay. Okay, so that's Mars, 500 million kilometers from Earth. And this is a Delta rocket. It's got 9 boosters. And the rover's in this nose cone.
SSC disconnected.
These are engineers talking to a launch director.
Let guys go. Hydraulics go.
And when all of the engineers tell the launch director go, they'll count down. I want you to count down with it. I will count down too. We do this every launch.
CLCDR, pad B, deck flush on. On. Pressures go. 10, 9,
8, 7, 6,
green board.
5,
4,
4. And when it
3,
gets down to 0, we all yell blast
1.
off and jump up and down and clap. So I want you to do that. Have some fun. Every time I see a launch, it's amazing. So you're going to see this rocket has 9 boosters. When it gets to a certain altitude and certain speed, the boosters will start coming up.
Which program is in?
They call Earth a pretty blue planet because all the water. So you're going to see a lot of different pieces on this mission. Each piece has a function. Some are for navigation to keep it going in the right direction, and some are for propulsion to keep it going at the right speed. Remember, it's got to overcome all of those variables of the planet spinning, going around the sun, different speeds, different orbits, so it's constantly adjusting. So you'll see when it goes by the sun, you'll see the sun and all the billions of stars in our solar system. And think about this. If you're in a ship and you're going to go to Mars, it's going to take you 7 months to get there. So that's a long time in a spaceship. When you come to Mars's atmosphere. And even though it's thin, it generates a lot of heat. So it has to have a heat shield to protect it, or else it would just burn up. And Mars's atmosphere is thin, so it doesn't slow down much going through the atmosphere. First thing will happen, a big parachute will open up. That will slow it down. Then the heat shield will fall away. Now you'll see the rover, it's in a canister. It's in this canister, and this is what Sojourner did. Sojourner went in a canister like this to test the ability if it could withstand it, the landing. So it's going pretty fast, so they fire some rockets. First it inflates, and then they fire some rockets to slow it down. And about 50 meters above the surface, they just let it go. And it bounces and rolls and bounces and rolls. Remember, it went 500 million kilometers. It took 7 months to get there. It's very fragile. And that's how it landed. Everything had to work perfectly. So the first thing will happen, it will deflate, and it's counterbalanced so it lands on its wheels. Solar panels unfold. They take energy from the sun. They convert it to electricity. That's what's used to power the rover. Then a TV camera comes up, and it takes pictures, and it sends it back to the Jet Propulsion Laboratory in Pasadena, California. Now, this is computer generated. It shows it cruising around Mars. But what it really does, it goes about 7 meters and it stops. It takes a picture. It's sent back to Pasadena. A geologist will analyze it and tell it what to do for the next 7 meters. So they went to Mars to look for water. But I want to stop this because we don't have a lot of time, and I'll just explain what happens. So if you look at the surface of Mars behind it, you see all of those rocks. That's what's called sediment. Scientists believe this was a huge lake one time, and the water dried up, and it has all of these rocks at the bottom. It's the same on Earth. If we have a big lake and it dries up, you'll see all of those rocks. So they think this was a big lake bed. So they went around Mars with this rover, and it has a drill on the front of it. We'll drill a hole in the center of a rock and look inside and take a picture and send it back to Earth. And then a geologist will analyze it and say whether water was present in that rock when it was formed and how old it is. They found a lot of water on Mars, above the surface, below the surface. So one of the things that happened with Spirit, one was Spirit and the other was Opportunity. Spirit had one of its wheels stick, So it couldn't go forward. So they turned around and they drove it around backwards. Spirit lasted actually about 6 years, and Opportunity lasted 15 years. This is what a sunset looks like on Mars. Pretty similar to Earth, but it's a little bit further away. So this is actually Opportunity. Now, Opportunity went the longest anything's ever gone on the surface of Mars, 45 kilometers. And it was only supposed to last 90 days, and it lasted 15 years. And what happened to Opportunity, they have these huge sandstorms on Mars, and they engulfed the whole planet. So what happened was that it wasn't a mechanical problem that made it stop. If you look at the picture on the left, you see all of those sand on top of the solar panel. That prevented from charging the battery, and that's how it died. Just not very long ago, but it managed to go 15 years. So this is Curiosity. Now, Curiosity is the latest one to be on Mars, and Curiosity is much, much bigger than Spirit and Opportunity. Curiosity is about the size of a car. It's 3 meters long, 2.7 meters wide, and 2 meters tall. And it went to Mars to study the climate and the geology. Now, Curiosity has a really cool laser. It can shoot a laser beam at a rock and blow a hole in a rock and take a sample. It has this fancy drill and take the sample of this rock and put it in the back where it has a way to analyze what's in it. Many of you listening may have chemistry or may take chemistry. If you take chemistry, you have a chem class and a chem lab. In the chem lab, you're analyzing things. That's what this is doing on Mars. Sometime you'll walk in a chem lab and a teacher will give you something. What is this? And you have to figure it out. So that's what this is doing on Mars. I want to show you how it landed on Mars. Now, not how it got there, but how it landed. Now, just like the other one, this is an Atlas rocket. You're going to hear them counting down. Count down with it.
T-minus 10, 9, 8, 7, 6.
These are lightning
5,
towers, these
4,
big white posts,
3,
so lightning doesn't
2,
hit the rocket.
1.
And then we
Main
say
engine
blast
start,
off, and then we all
0,
jump up and down and clap.
Lift off
And we all clap,
of
and I
the
want you to
Atlas
clap with
V
me.
with Curiosity, seeking clues to the
It's so much
planetary
fun
puzzle
to see this stuff.
about
I
life
hope you
on
get a
Mars.
little bit of appreciation from the movies.
Program is in right on time.
So we're not going to show you how it got there. You know how it got there, but I want to show you how it landed. The same thing, when it goes through Mars's atmosphere, it's generating a lot of heat. Now, Curiosity weighs about 1,000 kilos. And it's actually got steering rockets to go through the atmosphere at the perfect angle. It's also going very fast, so a parachute opens to slow it down. But with Curiosity, it has its own propulsion system that flies around Mars looking for a landing site, and that's called the sky crane. It lowers it down. And it's on Mars right now, and it's exploring Mars. Now, it's interesting. Mars Curiosity was only supposed to have a lifespan of 2 years, but it's been going 8 years, and it's still doing very well. It actually just started a new adventure going up a crater in Mars. So far, it's traveled about 25 kilometers. This is called Perseverance. Perseverance is very similar in size and shape to Curiosity. But Perseverance is supposed to launch this month, July 30th. I hope you'll be able to go to the NASA site, nasa.gov. You'll be able to see this launch on July 30th. Now, it was supposed to launch on July 17th, and it has a launch window from July 17th to August 11th. If it doesn't launch by August 11th, it's going to have to wait 26 months before it can go again, because the planets are traveling towards each other. At a certain point, they launch, so they'll be close to each other when they land, and then they get further and further away. So if it can't make that target date of August 11th, it's going to have to wait about 26 months to go again. It's, again, about the same size as Curiosity. It's about 3 meters long by 2.7 meters wide by 2.2 meters tall. And it's got some really cool features. It's got a weather station, and it's got a really cool drill. Now, the drill is different from the one in Curiosity, because what this does, Curiosity's drill took samples. This takes samples, but instead of analyzing, it stacks them. So it will go to certain types of rocks and take a sample and stack it, because future missions are going to come to Mars. They're going to pick up that sample and they're going to bring it back to Earth. And one of its main purposes is to see what we can use on Mars that's there that we don't have to try to bring with us. We know there's water on Mars, but we can't drink it. So there'll have to be some kind of purification. There's also carbon dioxide. We can't breathe carbon dioxide. So there's something called MOXIE. It's going to try to take the oxygen out of the carbon dioxide and convert it to drinking oxygen for astronauts. It also has a super camera where we'll be able to take much better pictures. And another feature is a little Mars helicopter. This is called Ingenuity, and it's really, really very small. It only weighs about 1.8 kilograms. Its chassis is only 14 centimeters long, and its rotor is only 120 centimeters in diameter, and it's solar powered. It's supposed to go there to test interesting targets for Mars to look at, and also plan the driving routes for the future rovers. Well, people say, what happened to Mars? You know, Mars was this planet at one time, and it had this great atmosphere, and it had lakes, and what happened to it? For the longest times, scientists thought a great big meteorite crashed through the atmosphere of Mars, and it all escaped. But about 2 years ago, they came up with another theory. We have solar storms and solar flares coming from the sun, and they bounce off Earth's atmosphere, and they give us the pretty northern lights, the aurora borealis. Our planet has a strong magnetic core that protects it. Mars has a weak magnetic core. So they think as these solar storms and solar flares were coming from Mars and hitting off of, coming from the sun and hitting off of Mars's atmosphere, as it was rotating over billions of years, it eroded away to what it is today. So this is a pretty cool picture. I hope some of you listening and some of you watching this will understand. We think this might be a future footprint, and one of you will have the opportunity to do this. You really will. There's going to be many, many opportunities. I think it's going to be 20 or 25 years before people actually can go to Mars. And when they do, there'll be many opportunities because many countries will develop the ability to do it in the next 20 or 25 years. So there may be opportunities. If it's something you think you'd like to do, I really encourage you to do it. The space program is fascinating, and you can do anything and be in the space program. So I don't know, do we have some time for questions? Do we have some time for questions? Do we have more time? No? So I'd just like to thank everybody. It's so nice to have this opportunity. I hope you enjoyed it. I say muito obrigado a todos. It's been wonderful. And hopefully I'll get to see you in Brazil before too long.
E chegamos ao final de mais uma Campus Party. Dessa vez a edição de Portugal, a edição digital de Portugal, Campus Party Portugal. E eu queria aqui pedir desculpas a alguns palestrantes que tiveram problemas técnicos e não conseguiram fazer as suas palestras, como foi o Dado Schneider, como foi o João Miguel, que agora a gente realocou ele para um palco, mas também não aconteceu. João Miguel, eu não desisti de você. Eu vou atrás de você, nem que seja para te receber no Porto, eu ir atrás de você em Lisboa. Eu vou atrás de você, não desisti de você, porque você é muito especial para a gente, assim como todos os palestrantes. Eu quero receber todo mundo aqui na Campus Party Portugal e em novembro estaremos de novo com mais uma edição digital, ainda esse ano, em 2020. Olha o spoiler aí. Ainda em 2020 estaremos com mais uma edição digital da Campus Party Portugal e eu não desisti de você, João Miguel. Quero estar com você, você é estratégico para nós, tem uma importância fundamental e nós vamos conversar muito ainda, ok? E aproveitar para agradecer pessoalmente a muitas pessoas. Primeiro eu vou agradecer aos embaixadores, ao pessoal da organização que não pôde estar com a gente aqui no estúdio e depois eu vou chamar o pessoal do estúdio para vir aqui para frente comigo e a gente fazer um salve para todo mundo aqui. Eu queria agradecer ao Carlos Vaz, ao Daniel Fangueiro, ao Marcelo Fonseca, a Ana Cecília Roque, a Ana Rita Regatão, Arthur Mimoso, Bruno Soares, a Cal, que está aqui no estúdio com a gente, o Cláudio Nascimento, o Eduardo Pamplona, o Henrique Martins, a Inês Ferreira Dias, a Isabel Azevedo, o João Anes, Margarida Campo Largo, Miguel Picão, Pedro Farinha, a Poli Sintra, o Ramiro Teodósio, a Romana Ibrahim, o Ricardo Martins, ao Tobias Azevedo e a todos os palestrantes que abrilhantaram a Campus Party Portugal e fizeram dessa edição uma edição maravilhosa, magnífica. Muito obrigado aos nossos parceiros OutSystem, muito obrigado a Páginas Amarelas, muito obrigado a Class, muito obrigado à Faculdade Nova de Lisboa, muito obrigado a Crino, muito obrigado a FTW, muito obrigado a todos, a Beyond, muito obrigado a todos os nossos parceiros que nos apoiaram e nos ajudaram a fazer uma Campus Party Portugal maravilhosa. E agora eu queria chamar o time que está aqui no estúdio, eu queria chamar a Lilian, o Caio, o Fábio, o Augusto, o Felipe, o Gilmar que está falando não, que ele não vem, o Gabriel, o Gilmar vai ficar pilotando o computador, está lá, todo mundo aqui de máscara, eles aparecem do nada, começam a entrar de repente aqui, está lá, todo mundo aqui na Campus Party Portugal, a Cal, todo mundo de máscara, todo mundo protegido aqui. Muito obrigado a todos vocês.